All right, average value theorem. Oh, it's been a while since we've done a theorem. Let's do a theorem today. So section 6.5 is our average value of function. And if we think about the average value, how do we find the average of a set of numbers? Well, we add them up and we divide by how many we have. And what we're looking at doing with integration is we're going to do the same thing. If we think about a graph, say we have an f of x here, and we're going from an A to B, then we can come up with the average value of this function. Well, what is that function talking about? That function can be anything. It can be drugs in the system after taking a prescription medication. It can be a vaccination. It can be people in a line, the number of people in a line. So it can be really a lot of different things. And we can find the average value of that. Well, what does that mean? Well, we're going to find how much is in this region. And to figure out how much is in this region, we integrate. We integrate from A to B of that function. Well, then how do I find the average? Well, I'm going to divide by how many things are in that region. And how do I figure out how many things are in that region, or how much distance is in that region? I go from A to B, or B minus A. And that tells me the average value. So the formula that we're going to be using is 1 over B minus A. That gives us the average, or averaging, the integration from A to B of f of x dx. That integration is going to give us that total area of this region. And again, we use the average value to find the average accumulation of something. So an example here I gave was the average amount of a drug in the system over a period of time given the equation of concentration of the drug. So if we know how much is the equation of how much drug is in the system, we can come up with then what the average amount is. Again, we could also figure out the average number of people in a line if we know how many total people were in that line over a given amount of time. So let's go ahead and look at a couple of examples. Maybe it'll be a little more clear than what that explanation was. Find the average value of f of x equals 2x plus 1 on the interval from 1 to 3. So again, our average value is 1 over b minus a. Our interval is going to tell us our a and our b value. So in this case, our b is 3 and our a is 1. Going from the integration of 1 to 3 of the function 2x plus 1 dx. All right, so we have 1/2 the integration from 1 to 3 of 2x plus 1 dx. We can integrate 2x plus 1. So I have a half. I'm going to leave that half out there. The integration of 2x is x squared. The integration of 1 is x. And I'm going from 1 to 3. Again, I'm going to leave that 1/2 out there for the time being. I'm going to plug in my 3. So I get 9 plus 3 minus, plugging in my 1, I get 1 plus 1. So I get 1/2 of 9 plus 3 gives me 12, minus 2 gives me 10, so that gives me 5. And that gives us the average value of that function from 2x plus 1 on interval 1 to 3. Example 2 there, we have the average value of the natural log of x over x from 1 to 2. Again, I'm going from 1 over 2 minus 1, the integration from 1 to 2 of the natural log of x over x dx. Whenever we're working with a natural log, we're going to do a u substitution. Yes, u substitution is not gone. So du then is 1 over x dx. So I'm looking at the integration. Well, 1 over 2 minus 1, that just gives us 1 over 1, or 1. Integration, again, since we changed it to u's, we're going to change these x values to u. So I have the natural log of 1, which is 0, to the natural log of 2 of u du. I can integrate u to u squared over 2 from 0 to the natural log of 2. Plugging that in, I get the natural log of 2 squared over 2, minus plugging in our 0, we get 0. So we can approximate that to the natural log of 2. And if you want to put that in your calculator, you can. Natural log of 2 squared divided by 2 gives us 0.240. And again, that's our average value of that function on that interval. And example 3, our last example for the day, again, a quick example day. We give you a little word problem. We have the concentration of a drug in a system is given by C of t equals 5e to the negative 3/10 t. Can we find the average amount of drug over the first 5 days in milligrams? And yes, we can. So what's going to happen is we're looking at the first 5 days, so we know that we're going from our interval is from 0 to 5, since we take it on the 0 day or at the beginning, and we end on the 5th day. So we have the 1 over 5 minus 0 gives the average. And then we're going from 0 to 5 of 5e to negative 3/10 t dt. Since we have an e, to integrate that, we're going to let e or u be the exponent of e. So du is going to equal negative 3/10 dt. I don't have a 3/10, I have a 5. It's kind of difficult to work with. So I'm going to go ahead and divide that over. So u divided by negative 3/10, du equals that, equals dt. 3/10 is 3 over 10, so this actually becomes negative 10/3 du equals dt. We can simplify this 1 over 5 minus 0 to 1/5. We can also bring that 5 out. Remember that 5 is being multiplied to the e, so that's going to be times 5. And we're also going to have this negative 10/3. So we can bring all those constants out since they're being multiplied together. Again, we did u substitution, so we're not going from 0 to 5 anymore. If I plug in 0, that stays 0. But if I plug in 5, I get negative 1.5, or negative 1.5. And that's e to the u du. Cleaning up this outside junk, I get negative 10/3. I can integrate e to the u, which is e to the u, and I'm going from 0 to negative 1.5. Now this is the first time we've seen this in examples where the top number now is actually less than the bottom number, which is okay, because remember, we replace these x values, and the x values were in correct order. So our u values could change. And if they do, we still take the top number, plug it in, minus the bottom number. So we have e to the negative 1.5 minus e to the 0. Again, we can go ahead and put that into our calculator. We have e to the negative 1.5, or negative 1.5. And if I can put that in the calculator correctly, negative 1.5. And then we're going to subtract off of it e to the 0, which is 1. And then we're going to multiply that by a negative 10 divided by 3. And that's going to give us approximately 2.589596 milligrams of concentration per day. And I guess that's per day there. So that tells us the average amount of this drug in our system over those 5 days. Enjoy average value.